Hey, Andy here again. So this time it's a little bit different video. This is part two of the MATLAB project that I've been showing you guys and hinting about. This is my enhancements on it. But this video is a little different because it's serving a couple of purposes. In addition to showing you what cool stuff I've been doing with MATLAB and this robotics demo, I actually took an image processing class this term at the University of Florida. And my final project for the image processing class actually dovetailed quite nicely into this demo. So I've actually had this done for a while and was just polishing it over the last few days. But I want to share with everyone what I did for both my class and for this demo. So just a quick rundown on the video here. I'll talk a little bit about the old demo. Then there'll actually be a little PowerPoint in here that I have to do as part of the class requirements, showing the different approaches I did and what actually my project was in terms of the classwork. And then I'll do a little demo, and actually this demo code is code that I wrote, but it's part of the demo I took to the Orlando Mini Maker Faire. But it's been stripped out and some things have been tweaked a bit so that you can see it. Obviously I've sent back the demo. As you can see behind me, there's no camera or anything hanging out here anymore. So the stuff has been sent back for a while to the MathWorks, but I want to share with you some static images, what it was doing to do that line detection and the waypoint generation and all that image processing. So really quick video here, about 10 minutes, so sit back and enjoy. I hope you enjoy the video. It was a lot of fun to make and a lot of fun to get to show it off with a lot of different people at the Orlando Mini Maker Faire. So check it out. So let's get to the PowerPoint. Like I said, I'm doing the line detection and generating the waypoints for a path. So this really starts off with the objective, which was to build upon the demo that the MathWorks had sent me for the Orlando Mini Maker Faire, leveraging MATLAB. The original demo, if you recall, formed a triangle with the robots based on a point that the user specified on the computer. I wanted to enhance this by allowing the robots to move around based on a line that a kid could draw. Now, this showed up about a week before the actual Orlando Mini Maker Faire, so I was under a tight time crunch. And of course, as with any of my projects, they have to work live. They had to be able to work at the Orlando Mini Maker Faire with kids and stuff interacting with them. So that really made me think about how do I get a good, reliable line detection algorithm and make this work with the requirement that it streams, that's interactive and working. As kids play with it, as well as making sure that it can account for the various levels of quality and noise that a kid might introduce. So this project really started off with a couple of key approaches. The first being looking at the pre-processing to try and reduce some of the processing overhead to keep us within our streaming. That basically required us to define a region of interest and mask over the robot. That greatly simplified processing as far as this project is concerned. The next is really how do we identify the lines inside these points of interest, and there's two key ways to do this. The most obvious approach, and the one that went live in the demo, was the binary image. It was the most straightforward. And then the second approach that I decided to explore for the project side of this was using image segmentation and trying to detect the color. All this was done by searching the edge of the ROI for the pixels, either being a 1 in the binary or the color that I'm looking for, which would be black in terms of the image segmentation. To pick which side of the ROI to actually analyze, we used the direction vector from the robot, which we already knew. So that made it really, really easy to actually search and find what we're looking for. This image has made its way around the internet and was my tease pick for this video. But actually what this is a sample image I gathered when I was running the demo in my apartment. As you can see, the robot and a black line are clearly easily found. The first thing that I need to do is to define a region of interest. So in doing that, you can see here in my MATLAB output, the blue box around the robot was determined based on the current robot position and its direction. I then cropped the image down, and as you can see on the cropped image, we have a beautiful slice of line as well as the robot. To simplify processing, I wanted to remove the robot, as you can see by masking it out with the white box. This allowed us to have a 20 pixel border around that white box that we were actually doing our processing on. Moving on to the binary image, we then took our cropped image down and converted to grayscale and did some processing. As you can see, this is what the user saw in MATLAB. The first bit there was defining the robot points, but you can see it outputs a waypoint. That image there is our grayscale. We actually inverted it because the MATLAB threshold functions are looking for white. And then you can see our final binary image. For that image we did an erosion, and then we did a dilation, and that removed a lot of the noise. Moving into the image segmentation, you start to see a similar output. In fact, our numbers for our waypoint match, but if you look at the segmented image, you will see very, very clear three color zones: white, beige, and black. Looking at the image, you can see that we just looked for the black line on the edge of the ROI, and in the binary we were just looking for the one value, the white intersection, and like I pointed out earlier, the waypoints do match, and that indicates that both methods produced usable results, which was good to see. So great, what does all this mean? Well, in the scope of my demo, it means it worked. But in terms of my project, focusing on the smaller ROI really helped decrease processing time and increase the effectiveness. Both line detection algorithms worked, but image segmentation, just from a coding and logic standpoint, was really much more complex to think about and to create and function correctly. The issue being that you're searching for a color, you're not searching for a binary value, so you have to look at all RGB, and you can sometimes have some issues if they aren't all correct. But the good news was that the ROI really was effective for this. The ROI ended up being like the perfect distance away from the robot for formulating a good path and a good set of waypoints. And it followed the curve really, really well. In the live demo. I wish I had it here to show you more in person, but believe me when I said it looked pretty spectacular. And I think this was just kind of finding that sweet spot in terms of both processing time, distance, and good detection rate with our different line detection. Moving into our static demo here, I'm using the same image that we've seen. When I run it, I first have to select where the robot is. This is actually already done by the MathWorks code, but I stripped that all out just to make a nice little turnkey demo for this video. And I select the pink dot in the middle of the robot. That's kind of the exact same point that the MATLAB demo uses to give the robot's location. Based on this location, I can then generate my region of interest around the robot, which will give me a good idea of where the robot needs to go. The next step is to define the front of the robot. In the MATLAB demo, you'd use the green line that's currently there, but again, I don't have that infrastructure here for this demo. I want to make it turnkey for my professor, so I just click on the screen. As you can see, it then generates my two cropped images, the first one here on top being the masked out one, but if I move it out of the way, you can see just the regular cropped down image that you saw in the PowerPoint. Again, this is just a quick little cropping down. Nothing particularly special. I do manually go through and actually assign the white value there, so I know it is pure white. I didn't generate a mask or anything, and I draw a square roughly around the robot based on its current vector. After that, and if I like this, I can then hit my button to continue, and you can see I generate my binary images. The one right here on the lower left corner is the grayscale. I had to invert it because the MATLAB functions for doing its thresholding are looking for a white value. So I need to convert that big white square to black. And then as you can see here, I have my beautiful thresholded value. And on this I did a dilation and an erosion. This made all the blobs connected and removed the noise that was there. As you can see, there are some valid points on the bottom part of the ROI, but due to my search algorithm and using the direction vector, I'm only looking on the left side to actually do the processing. Now when I do my segmentation, I generate one more image. You can see there's three very, very clearly defined colors here: the tan paper, the black, and the white. Again, it also does show a larger black area, but if we do our diff between just the cropped down one and the segmented one, you can see that it took a lot of the black shadow there and actually colored it as black. You could tune sort of the ranges for the segmentation if you really wanted to, but again, part of this was being adept to noise. So if you really tuned it too narrow, you might be excluding data. But all in all, it seemed to work very, very well. So as you can see, the project came together really, really well. It worked. I was able to easily integrate into the time slots allotted and have a very, very successful project. The biggest issue was lighting and getting that to work with actually picking up the robots in the first place. Since my code was doing mainly binary image processing, it was fairly immune to the lighting issues. But yeah, it worked, and I really can't complain. I hope you enjoyed it, and if you want to see more about this project, about other projects, check out my blog. Link is right here on the screen, 08maloos.wordpress.com. In terms of what I'll be doing now and in the future. I have a few more projects coming down the pipeline here in the next month or two, depending on with the holiday craziness when I can get them up. But hopefully you enjoyed it, and hopefully you enjoyed learning a little bit about the magic behind what went into the image processing for my demo. Thanks for watching.